Basically, any expression of this form, which is like this, a0 plus a1x plus a2x square plus a n xn a n into x to the power n. Uh, any expression of this form is called a polynomial function, wherein uh, uh, all that is all the coefficient a0, basically a0, a1, a2, an, all together are not zero. Means some of them could become zero, but not all of them would be zero at one point of time itself. So not everything will be zero at the same time. And moreover, the power of x basically is an integer. So n, basically n, which is an exponent or power of x, should be a positive integer. So if it is not a positive integer, then this is not a polynomial. So for example, the simple polynomials, one of the simplest polynomials we know is px equals to x. So this is one of the simpler polynomial, or it is also called, well, let me just write a better one. So the other, something like a0 plus a1x. This will be called a linear polynomial. And it's a because the power exponent of x is over 1 here. Exponent is x is 1, so this will be called a linear polynomial, wherein px, like a0 plus a1x plus a2x square, would be called a quadratic polynomial. And px equals to, say, a0 plus a1x plus a2x square plus a3x cubed would be called cubic polynomial. So what we are doing over here is that we are looking at the highest power of each, basically highest power of x in each of these expression, and based on that we are deciding what the name would be. So in this case, the power x, highest power of x was 1, highest power of x was 2, highest power of x was 3. So because of 2, quadratic it's called, because of 3 it's called cubic. So quadratic means basically 2, quadrat is 2 basically, and because of this reason it's called quadratic polynomial. Cubic again, 3, because of 3 it's called a cubic polynomial. Even this one would be, for example, would be called a linear polynomial, wherein, oops, it will be called a linear polynomial wherein, say, I just have x here. So what has happened here is a0 is actually, if I compare with this, a0 is 0 here, but a1 is actually 1. So this is also called a linear polynomial, and similarly this will also be called a cubic polynomial. So polynomial itself, because other terms like a0, a1 and a2 all are 0 here, but a3 is 1 here. So because of this reason, this is also going to be called a cubic. This is going to be called a linear. This is the generic form of a linear polynomial, and in this case, a0 has become 0 here, a0 and a1 have become 0 here, a0, a1, a2 have become 0. So, but they still would be called a polynomial, and which will not be called a polynomial is, for example, if I have px, something like, say, 1 plus x to the power 3 by 2. So though here I have got x to the power 1, but this is a fraction here. So because of this reason, not a polynomial. It's not a polynomial for me. And similarly, if px is something like 1 upon x plus 3, it's also not a polynomial, because essentially it is nothing but x plus 3 to the power minus 1. And it's also again not a polynomial. Even if it is like p upon 1 plus x to the power 3, this is not a polynomial, because if I get the power up over here, it will become x to the power minus 3, and minus 3 is a negative integer. That's the reason I will not be calling it a polynomial. But say if I have px equals to 1 upon x to the power minus 4 in the denominator, essentially it is x to the power 4, and it is a polynomial. polynomial of fourth degree. So we call the degree of the polynomial basis the highest power of, basically highest power of x in the expression is called the degree of the polynomial. I hope this you have studied in the last class also. Degree of the polynomial. If someone asks you that what is the degree of polynomial here, this is the first degree polynomial. The degree is 1 here. This is the second degree polynomial. The highest power is 2. This is the third degree polynomial, and the one which I just showed you, it's a fourth degree polynomial. This is a fourth degree polynomial because the highest power of x is 4 over here. Okay. Okay. I'll have to also tell you the coefficient relationship between the coefficient as well. Okay. So let's learn that as well. Let's move forward. Okay. Maybe we can look at some of the examples here and say. So as I mentioned, expressions like 1 upon x minus 1, root x plus 2, 1 upon x square plus 2x plus 3 are not polynomials. And we call what is a linear polynomial, what's a quadratic polynomial. Here too, if the coefficient is basically irrational, doesn't matter. Basically, quadratic polynomial whose coefficient are real numbers. So you should not get confused if the coefficient becomes basically uh, irrational. Even if it is irrational, it is still a polynomial. Okay, even if it is negative integer or fraction, it will be still a polynomial. So what I mean here is that though we say that this is not a polynomial, but say if I'm writing root 3x plus 5x square plus 6x cube, if I write it like this is still a polynomial, though there is a irrational number here. This is a polynomial of third degree. Okay. Now we'll learn something. The value of a polynomial at a point. The value of a polynomial at, at a point. You can say at a point or at a anything. So, for example, if you have an expression like this, px is equals to 1 minus x square, and if I'm putting this like this, p x is equals, what is the value of this expression at x equals to 0? So I will just put p 0 here wherever x is there, and wherever x is there I will put 0, so it will become 1 minus 0 square, so this will become 1. Similarly, if someone asks me the value of p1, what is the value of polynomial at x equals to 1, it will become 1 minus 1 square, which will be 0. And similarly, when it is at p at, at x equals to minus 1, again it will be 1 minus 1 whole square equal to 1 minus 1, which is 1 of equal to 0. So the expression which makes this expression 0, so 1 and minus 1 for example, would be called the zeros of this polynomial. So for the values at the values of x at which px becomes 0 is called the zeros of the polynomial. We call these zeros, we sometimes call these as roots as well. So in this case, in above case, 1 and minus 1 are zeros of px. So these are called zeros of this polynomial. So I hope this is working fine. So for example, if I have an expression, let's take the example from the book itself. So expression like x square minus 3x minus 4, px is plus x square minus 3x minus 4, and I'm asked to find the value of this at x is equals to minus 1. At x equals to minus 1, what will be the value of px, the polynomial? What I will do is, again, I will just put wherever x is there, I will put minus 1. So here I'm evaluating polynomial's value at x equals to minus 1, which is p minus 1, and here it will be minus 1 square minus 3 into minus 1 minus 4, and this will become 1 plus 3 minus 4, which will become 4 minus 4, which will become 0. So let's say I have a linear function, linear polynomial, which is something like a0 plus a1x. Sometimes we also write it like this, a plus bx. Similarly, if I have a quadratic like this, a0 plus a1x plus a2x square, we also write it like a bx equals to a plus bx plus cx square, or we can as well write it as bx equals to ax square plus bx plus c. We can actually change the order as well. So basically, what that we are trying to write over here is that these are constants. So if px is written like this, as I was writing a0 plus a1x plus a2x square, I can write it as well like ax square plus bx plus c. Similarly, just to maintain the same thing over here, we will write it like px is ax plus b over here. And for quadratic, for example, if it is px is equals to a0 plus a1x plus a2x square plus a3x cube, we write something like px equals to ax cube plus bx square plus cx, cx plus d. So, so what I've done here is that basically all these constants I'm just changing to the format in which we generally make use of it. So going forward, let's use this ax plus b. For quadratic, let's use ax square plus bx plus c, and for cubic, let's use ax cube plus bx square plus cx plus d. So now let's talk about the linear polynomial first. So now we are going to talk about px equals to ax plus b. So we are trying to find the zero. So you will also learn that whatever be the highest degree of the polynomial, those many zeros will be there for the polynomial itself. So for a linear polynomial, there will be only one zero. For a quadratic polynomial, there will be two zeros. And for a cubic polynomial, there will be three zeros. So, and so on and so forth. For n degree polynomial, there will be n zeros. So in general, I can just write for n degree polynomial, there will be n zeros. Okay, so at least for this one, I want to get the zero, so I have to equate it to zero. So then I can just get x is equals to minus b by a. So the first thing is that if you have only one zero, it will be equal to minus b by a. What it means is if you put b equals to minus b by a, x equals to minus b by a, so it will be x into minus b by a plus b, a will cancel out, minus b plus b, it will become 0. So you will say that the 0, in case if you have 1 0, it will be x equals to minus b by a. For quadratic, let's talk about the quadratic also. And this is where we will be spending most of our time. So quadratic polynomial will be of the form ax square plus bx plus c. and as oops, it will be like this. So when you want to get the values of the zeros, you'll have to equate it to 0, and what you will find out here is that the if say you have two zeros of this, right, the sum of zeros will be actually equal to minus b by a, and product of zeros will be equal to c by a. So uh, this is more of a quadratic equation, and you know that how to evaluate the what do you call the zeros of it, right? Have you learned how to evaluate the zeros of a given quadratic equation? So this is kind of a rule we will learn now. Okay, so we'll try to figure this out. Let's Since I've started, I'll let me talk about this, and then we'll see what I mean by this. So say for example, I have a polynomial of this form px is equals to say x square minus 5x plus 6. Okay, so I have a polynomial of this form x square minus 5x plus 6. So I have to find the zeros of this polynomial. Okay, now if I have to find the zeros of this polynomial, say if I'm putting p equals to say I'm putting p equals to 2, let's say what happens here. So this will become 2 square minus 5 into 2 plus 6. So this will become 4 minus 10 plus 6, which will be 10 minus 10, which will be 0. What if I put p x is equals to 3? So this will become 3 square minus 5 into 3 plus 6 equals to 0, which will be 9 minus 15 plus 6, which will be again 15 minus 15, which will be 0. So what I've got here is that I've got two zeros of this polynomial, which are 2 and 3. And so when I do the sum of these two zeros, so I'm just saying sum of, what are the two zeros? First of all, let's write. So zeros of px equals to x square minus 5x plus 6 are 2 and 3. Now I want to evaluate the sum of zeros here. If I evaluate the sum of zeros, it will be 2 plus 3, which will be 5. And I want to evaluate the product of zeros also. Product of zeros, which will be again 2 into 3 equals to 6. Now I have done this, but something like a result I have written here, that for the quadratic polynomial, the sum of zeros will be equal to minus b by a, where is b is the coefficient of x and a is the coefficient of x square. If I compare this with the earlier one, I get b equals to minus 5 and a equals to 1 and c equals to 6. If I'm comparing this expression with x square plus bx plus c equals to 0. If these two are basically equal, then these two are equal, then a has to be equal to 1, b has to be equal to minus 5, and c has to be equal to 6. And going by the formula, the sum of the zeros according to this formula would have been, sum of zeros would have been minus b by a, and minus b is minus 5 and a is 1. So I will get 5 by 1, which is 5, and this is what I had got over here also. Now if I am going to get the product of, so what I'll get c by a, while my c is 6, a is 1, I'll get 6. So this is also using the formula, I will get this. So you can verify this result using any quadratic polynomial, and it will be true for all of them. So for example, if I have another polynomial of the form, say x square minus 4x plus 4, which is nothing but x minus 2 whole square. So I've just written it this way. And if I want to get the zeros of this equation, what I'll get is that px is equals to x minus 2 whole square. And in this case, essentially what it means that when I put p2, I'll get 2 minus 2, which will be 0. So in this case, as it's a 2-degree polynomial, what do we say here is that the two roots are equal. So the two roots or the two zeros would be same here, and it will be 2 comma 2. So they are both equal here. So if I'm just going to do sum of zeros again, if I do sum of zeros here, it will be 2 plus 2, which will be 4. And if I do product of zeros, it will be again 2 into 2, which will be 4. And if I use a formula and try to compare it with ax square plus bx plus c, so if I compare it with ax square plus bx plus c, I get a equals to 1, b equals to minus 4, and c equals to 4. And according to the formula, sum of zeros is equal to minus b by a. And here minus of b is minus 4, a is 1, so I get 4. And if I want to get product of zeros, the formula says that c by a. My c was 4, a is 1, so I'll get 4. So the sum of zeros and product of zeros again is gonna come same as this. So we are not proving it, we are just verifying things over here, that this is the result. We are saying that if you have a quadratic expression, the sum of zeros is gonna be minus b by a, the product of zeros is gonna be c by a, and this result is going to be true for any quadratic polynomial. Okay, so irrespective of whatever be the roots or zeros of the equation, this result will hold true every time. Okay, now let's understand what is given here is that the geometrical interpretation of the zeros itself. So let's start with the first example, wherein we had uh, px is equals to ax plus b. So in this case, I will just take the simple case wherein my px is gonna be x plus 1. So when you plot it, you what you do is you just take it as a line. So now px is treated as a function of x, and it is more like treated as y is equals to x plus 1. And what do we do is we actually plot the line, which will be like this. So if I want to plot the graph of y equals to x plus 1, so what do? I generally, if we have to plot a graph, we put various values of x and then get different values of y to plot the graph. So for example, if I have say x here, y here, I will put x is equals to 0, then I get y's value will be 1, 0 plus 1. Then let's say I put x equals to minus 1, then I get y equals to minus 1 plus 1, which will be 0. Then I put some other values, but two values are enough for us to plot the line. But say if I put another value, which will be x equals to 2, then I'll get y equals to 3, and so on and so forth. So if I have to plot it, I will be like writing like 0, oops, 0, 1, 2, 3, and this side will be minus 1, minus 2, minus 3. Here 2 it will be minus 1, minus 2, minus 3 somewhere. Here it will be 1, 2, 3. So I'm just making the division approximately, but you will be using the graph paper and you will know the exact places wherein you have to plot it. For x0, y equals to 1. At x is equals to 0, y is equals to 1. So this is the point here. One point. When x is minus 1, y is 0. When x is minus 1, y is 0, the point is over here. When x is 2, y is 3. When x is 2, y is 3, the third point is somewhere over here. And once we have got the point, we can just draw the line. Now I can just draw the line and which will pass like this. So what is the interpretation of 0? As you could understand, so this has to become 0. So this, if I am writing x plus 1 equals to 0, so this will become x equals to minus 1. So here, wherever the line cuts the graph, so it is cutting the x-axis at x is equals to minus 1. So that will become the 0 of this equation. So since this is a linear equation, it is gonna cut the x-axis only once, and it will be actually the point at which the line cuts the x-axis will be called the 0 of the polynomial. 0 of the polynomial. This is for linear. Let's talk about another polynomial, which will be a quadratic polynomial. So this is gonna be my let's take the simple case wherein whichever we are taking x square minus 5x plus 6 we are taken, and let's try to plot the graph again. So we will be taking values of x and y and trying to plot the graph. So let's go to the next page and do this. And let me also take, let's try to use this form wherein what I was saying, I will be having px is equals to x square minus 5x plus 6. So what I'm trying to do is I'm going to actually get the different values. Mm, this is my x and I'm going to call this y. So I'll put different values of x and y. So I'll put x is equals to say 0. When I put x 0, it will be 0 minus 5 into 0 plus 6, which will be 6. Then I put x equals to 1, then it will be 1 minus 5 into 1 plus 6, which will be 2. So 1, and this will become 2. Then I'll put x is equals to 2. What I'll get here is I'll get 2 square minus 5 into 2 plus 6, which will be 4 minus 10 plus 6, which will be 0. Then I'll put 3. Then what I'll get here is that x is equals to 3 square minus 5 into 3 plus 6, which will be 9 minus 15 plus 6, which will be 15 minus 15, which will be 0. Now I put x is equals to 4. Then I'll get 4 square minus 5 into 4 plus 6, which will be 16 minus 20 plus 6, which will be again 2. So I've got so many values. I'll try to make use of it and try to plot the graph and see how it goes. So I've got this line. I've got another. Let's shift it this side because I have all the positive values only. So now I'll use x 0 here. 1, 2, 3, 4, 5, and 6. And here I'll be having uh, again 1, 2, 3, 4, 5, and 6. So at x is equals to 0, y is 6. So I've got this point. I've got this point. When x equals to 1, y is 2. Then I've got this point. When x is 0, 2, y is 0. I've got this point. When x is 3, y is 0. I've got this point. When x is 4, y is 2. I've got this point. So if I put any value in between, let's say I'm putting a value in between which will be 5 by 2 here. Let's put 5 by 2 to see what happens. If I put 5 by 2, 5 by 2 whole square minus 5 into 5 by 2 plus 6, I'll get 25 by 4 minus 25 by 2 plus 6. I'll get this will be minus 25 by 4 plus 6, which will be minus 25 plus 24 by 4, which will be minus 1 by 4. So I'll get somewhere in between here minus 1 by 4, which will be somewhere over here. Oh, so this was a point over here. So what I'll get a curve as, the curve will look like something like this, that I have to join these points freehand. So it will go like this and go like this and go like this again. So this is a curve which is looking like with what we call as a parabola. You will learn later. This is called parabola. But what is that I want you to observe here is that this curve is cutting the x-axis at 2 points. One over here, one is over here. So as many times it has cut the x-axis, this curve has cut the x-axis, there are so many zeros available. So as many times the graph will cut the x-axis, there will be so many zeros of the equation. So in this case, the graph has cut the x-axis at 2 points, so there are two zeros here. While this graph has cut the x-axis at 1 point, so there is one zero available. Similarly, if it is a cubic equation, you would see that basically the graph might look like this at times. There will be various polynomials. The graph could look like something like this also. For example, there could be a graph, oops, there can be a graph which can look like this, this. So as many times it will cut the x-axis, there will be so many zeros. So in this case, there will be 1, 2, 3, and 4. For this will be maybe a polynomial of fourth degree, and since it is cut the x-axis at 4 times, so there will be 4 zeros of this quadratic, sorry, this polynomial equation. So this is something which is there over here, which they are trying to tell you by plotting different graphs. And say I have shown you when the graph is cutting the axis, right? So here I had just plotted a graph of this function like this, and it has cut the x-axis 2 points here and here. As you could see there, that there are 1 0 is basically 1 0 is at x is equals to 4. 1 0 is at x is equals to 4. Another 0 is at x is equals to minus 1. At x equals to minus 1, there is a 0. So the polynomial's value will become 0 here and here, and as you can see, these are the places where the graph is cutting the x-axis. So this is one. Now there's another situation wherein the graph is upside down and still it is cutting the graph at sorry, x-axis at 2 points. So in this case also there will be two zeros for this equation also. Here too there will be two zeros. Here, what has happened? The graph is only touching the x-axis at 1 point. So in this case, there will be only 1 0 because it's not cutting the x-axis at 2 points. And this is the case which I was trying to show you when you would plot the graph of this equation x minus 2 whole square, right? So you will see that in this case, there will. Oh, let's try doing this graph also so that we'll understand. So let's say I have got the polynomial was this. I had got x square minus 4x plus 4 equals to 0, which I told you is nothing but x minus 2 whole square. If you want to plot the graph of this function, what you will have to do is you will just put different values of x and then you will get different values of y. So I'll put x equals to 0, then I will get 0 minus 2 whole square, which will be 4. Then I'll put x equals to 1, then what I'll get is a 1 minus 2 whole square, which will be basically 1. Then I'll put x equals to 2, then I'll get 0. I'll put x equals to 3, Then I'll get 3 minus 2, which will be 1 square. I'll get this. I'll put x equals to 4. I'll get 4 minus 2 whole square, which will be actually 4 itself, and so on and so forth. But I will just stop here. And when I'm trying to plot the graph of the function, I have got 0 here. I've got 1, 2, 3, and 4. And while I've got 1, 2, 3, and 4 over here. When x was 0, y was 4. When x was 1, y was 1. When x was 2, y was 0. When x was 3, y was 1. When x was 4, y was 4. So again, when you plot the graph, it will look like this. So the graph will look like this. And as you can see, the graph is actually just touching this x-axis once and leaving. So in this case, there will be 1 0 actually, but we say that if there are two zeros, basically they are both equal. So it means that there is only 1 0 over here. And that is what this graph is showing you. And this is what this graph is showing you. This is what this graph is showing you. So there will be only 1 0. Only 1 0 in this case. In this case, there will be no zeros. Basically, you will not get uh, any zeros. Though this is a quadratic equation, but then you will say that you just told me that if for n degree polynomial there will be n zeros. So this is, if it is a second degree polynomial, there should be basically two zeros here. But what happens in this case is that the two zeros will be not real roots, but they will be complex roots. Rather, we will learn about them later. They will be sort of complex number, and though there are two roots there, but they are not real roots, so we will say that there are no zeros in this case. In higher class, we will learn that the zeros are there, but they are just imaginary. They are not the real zeros. So, but for this class, we will be just saying that if the graph is not cutting the x-axis, then there will be no zeros. Similarly, all these graphs, as you could see that as many times it will be cutting, there will be so many zeros here. So here there will be 1, 2, 3 zeros. Here there will be, we'll have to see whether this is gonna cut at 1 point or many points. This is gonna be actually 1 because it's gonna only touch once and then leave. So one time only at 0 it is happening. In this case, it's happening at 0 and 1, so there will be two zeros here. So similarly, here there will be 1 0, there will be 2 zeros, there will be 3 zeros, there will be 1 over here, there will be 1 over here, there will be 1, 2, 3, 4 here, 1, 2, 3, 4, 5. There will be 5 zeros here. Just go through this, whatever I have told you. Look through the exercise again. Try to see and plot a few graphs yourself. For example, let's plot a graph of this function yourself and see whether you are able to get the zeros in this case. X cubed minus 4x. This graph you plot and see that whether these zeros are making sense to you. Similarly, these few graphs like y equals to x cube and y equals to x cube minus x square. These graphs you create yourself so that you get an idea. All right.